Hi guys, today I want to talk about Pandas. So Pandas is the Python library which is used for heterogeneous data management. So most of the time we are having data in different kinds of files like CSV, Excel, JSON or SAS, SPSS. So when you have data in such kind of files, so we'll load the data, we'll create a data frame and then we'll perform different kinds of operations. So that is the main use of Pandas. um, Data handled by pandas or no tabular data. So when you have a tabular data in Excel or in RDBMS, relational database management system, so you can load the data and create a data frame. Then time series data means the data which changes with respect to the time, like stock market, weather data. So that kind of data can be handled. And matrix data, where we have rows and columns or any other kind of observational or statistical data sets can be handled. Then what are the features of pandas? So pandas supports handling your missing data automatically. So when some cell is not filled in Excel or in CSV file, then that is automatically identified as NaN, stands for not a number. Means it represents missing data. And size mutability means you can increase or decrease the number of columns and rows. So that is possible. And automatic and explicit data alignment. Data alignment is done automatically and it supports flexible group by functionality. You can group the data based on some attribute. And this is very interesting, intelligent label based slicing. So far if you have learned the basics of Python, so you can access a particular item by specifying the position or slicing, doing slicing. But here you can also specify the column name or a row label. So that's an interesting feature. And merging and joining of data set is possible, and reshaping and pivoting of data set is also possible, and hierarchical labeling of access, and very importantly supporting various IO input output tools for loading and storing the data back. And as I mentioned before, time series functionality can be supported. So these are the striking features of pandas. So pandas supports two data structures. The first one is series and the second one is data frame. So series means one dimensional data. You can, when you have a one dimensional data, you can create a series. And data frame is two dimensional, where you can have rows and columns. And data alignment is intrinsic, means you can just automatically done. So let us see first how to create a pandas series. So as I mentioned, series is one dimensional. The syntax to create a pandas series is this. Series, you have to use the predefined method series. In that, S must be capital because Python is case sensitive. And this function takes one important parameter, that is data. What is the source of data? And then index, you can specify the index. So series can be created in different ways. When you have an array, Numpy array, you can create a series, and from dictionary also you can create a series, and from scalar value also you can create a series. So let us first see how to create a series from Numpy array. So Numpy is used for uh, creating multi-dimensional array. So in other terms, n-dimensional array. So here we need to import pandas. So no need to install pandas because it automatically comes with Anaconda. So importing pandas as PD. So PD is alias here, and importing numpy as well here. Numpy is to create a multi-dimensional array. So np is the alias, and then first I'm creating my data. So my data is numpy array, np dot array of, and this is the list of values, list of elements a b c d e. So I'm just taking sample data. So from this data creating a pandas series here. So s is user defined name, which is equals to pd dot series of data, and then I'm printing the series. So this is the output. So it is one dimensional, and this 0 1 2 3, so they are the indices, index. So if you want to access a, then you need to specify the position 0, like that. So here we have default indices 0 1 2 3, We can also define our own index. So same data set is used here, but we are adding index is equals to 100, 101, 102, 103. So we have four elements, so specifying four index positions. Now instead of 0, 1, 2, 3, so we have 100, 101, 2, 3. And these data elements are string types. So that's why D type means data type is object. So this is how you can create a series from Numpy array. Next we'll see how to create a series from dictionary. So dictionary means which is having key value pair. So my data over here is a dictionary. So A is a key and its value is 0. B is a key, its value is 1. Then C is a key and its value is 2. So creating series from data here, so which is dictionary. So one point to be noted over here is for dictionary, keys acts as indices. Okay, keys acts as indices. You see it by default. A, B, C are the indices. So to not to access the element 0, I need to specify the position A like that. 1 for B, C for 2. So this is how the series is created from dictionary. Then in the next cell, I'm specifying the position. So these are the default ABC order, but we can also specify the order in which in which way you want to display the elements. So I'm specifying the index as B, C, D, A. So first B, then C, then D, then A. So first B is 1.0, C is 2.0 here. Actually, we don't have D. So that's why, as I mentioned in the features, if the data is missing, it automatically recognizes that as NaN, means missing value. So there is no index D and there is no value with that. And as you have missing values, the data type of these values are automatically changed to float. So 1.0, 2.0, 0.0 like that. And you can also see the data type of these values are floats 64-bit. Then let us see how to create a series from scalar. So scalar means single value which is constant, which cannot be changed. So I'm directly giving the data as 5 here, value as 5, but multiple indices 0, 1, 2, 3. So 4 elements. For the element is same. It is copied for all the indices 0, 1, 2, 3. Next, these are the properties to get the index of series. So these are the indices 0, 1, 2, 3. Values means we'll be getting only values 5, 5, 5, 5. So this is how you create a series. Next, importantly, you need to know how to access elements of a series. In that case, you need to specify the position. So here, again, I'm creating a series here. The elements are 1, 2, 3, 4, 5, and the indices are A, B, C, D, E. So 5 elements and 5 index positions, then displaying the series. So this is my series. Then I'm accessing the element C. Okay, S of C means what is the element at the position C. The element at the position is 3. You can also specify the list of indices. So using 2 square brackets because you have list of indices. So A value is 1, C value is 3, D value is 4. You can also use this function s dot at A means what is the value at the index A. The value at the index A is 1. And this is slicing. We are specifying the sequence of indices A to C. So A to C means A, B, C. The values are 1, 2, 3. So these are the elements. So 3 elements are displayed. So far we have seen how to create a series and how to access the elements of a series. Next important data structure is data frame. It's nothing but series of series. So when you have a data in some spreadsheets or in RDBMS or also getting from dictionary or series, you can create a data frame. So here are the couple of examples or different ways of creating data frame. So how to create a data frame from list. So my data is list here. So list is created by using square brackets. I hope you have Python basics. And creating a data frame from list. So pd dot data frame. This is predefined. So pd dot data frame of data. Then the data is created. Data frame is created. So single column is there. where the label of the single column is 0, and how many rows are there? 0 to 4, 5 rows are there. So data frame means two-dimensional, where in you can have rows and columns. Then this is another example. My data is list of list. Each element is again a list, and then creating a data frame, and this columns is the property to the data frame. We can specify our own columns. As you can see, these are the default row labels and column labels, but here we are giving the column names, name and age. So name is the first column name and age is the second column name, and the row labels are 0, 1, 2, 3 here. So in the next cell, the same, but there is a difference here. I can say this is list of items. So we are using normal brackets. So list of items. So from this also data frame is created. Next, we are giving data types, but I think in the future this is not going to be no applicable. So as you can see, the warning machine could not cast to float 64-bit. This is going to be deprecated. In the future, data type has to be applied on the complete, otherwise it is going to raise a error. So this is the data frame. Now d type equals to float means data types of numerical columns have been changed to float type. Next, creating a data frame from a dictionary of Numpy ND arrays or list. So this is dictionary. My data is dictionary here. Key is name, and then its values or list, and then age is a key, and we have list of age values. So creating a data frame from dictionary. The dictionary values or list type. So this is the data frame, name and age. So instead of having those default indices like 0, 1, 2, 3, 4, we can also specify the index here. Index equals to like rank 1, 2, 3, 4. So we'll be having user defined indices. Rank 1, 2, 3, 4. Then creating a data frame from list of dictionaries. So we have list of dictionary, multiple dictionaries here. So we have two. So this is the first dictionary, and in which we have two elements. A is the index value is 1, B is the index value is 2. Then one more dictionary is there in which we have three elements. Now from this, creating a data frame. So ABC are the columns. So ABC, but in the first dictionary you don't have the third value, so that's why NaN means missing value. Then creating a dictionary, but this time we are giving the index, so in first and second. So the difference between 34 cell and 35 cell is we are giving the index here, first and second. The columns, what are columns here? The columns are the keys A, B, C, like that. Sorry. And then creating a data again, but this time creating two data frames, same data but two data frames. df1, in that I'm accessing columns A, B, and then df2, in that accessing the column A and B1, but B1 does not exist, so you are getting missing values. So this is my first data frame A, B, and this is my second data frame. So in second data frame, B1 index is not there, B1 key is not there, so that's why NaN missing values. Next we'll see how to create a data frame from dictionary of series. So my data is dictionary type here, but its values are series type. So three elements, three indices A, B, C. Then again in the second one, four elements, four indices A, B, C, D. So from this, creating a data frame. So two dictionaries are there, so two columns 1, 2. In the first dictionary we just have three elements, so no fourth element, so that's why missing value, and its data type has been changed to 1.0, 2.0, 3.0. So as you have missing values, the data type is converted into float, otherwise it would have been only integers. So we have learned how to create a data frame. Next, importantly, we'll see how to access columns, how to select a column, how to add a column, and how to delete a column. So creating a data frame here, the same like we did in the previous cell. So this is my data frame. So how to access the first column? The syntax is df of in the bracket you need to specify the column name. So column name is 1. Then it will display the first column like 1.0, 2.0, 3.0 and NaN. You can also specify the list of column names. So df of 1 comma 2, then 2 columns are accessed. You can also do like this, df dot 1 means accessing the first column. So in this format is used to specify only single column. We cannot specify multiple. And then how to append one data frame to the another one. So we already have a data frame. So to that we are adding one more column. So df of 3 which is equals to pd dot series of, these are the values 10, 20, 30 and positions are A, B, C. Then column 3 is added to the existing one, 1 and 2. So now we have 3 columns, 1, 2, 3. Then how to add 2 columns, and then here I'm creating a new column 4. So df of 4 is equals to 1 plus 3. The values of column 1 and values of column 3 are added. So here 1 is 1.0, column 3 is 10.0, the total is 11.0. Similarly 2.0 here plus 20.0, the answer is 22.0. Similarly 33.0. So here NaN cannot be added to NaN. NaN plus NaN is NaN only, missing value. Next, how to delete a column. So you can use del, then specify the column. So df of 1. So I would like to display the first column. So it has been deleted. So the remaining columns are 2, 3, 4. Okay, 2, 3, 4. So you can also use pop function, df dot pop of 2. Pop of 2 means I want to remove 2, the column label 2, then remain columns are 3 and 4. So this is how you can select, add and delete a column. Next we'll see how to access row, how to add a row, how to delete a row. So this can be done by using the locate function. LOC means locate. So creating a data frame and displaying again, and from this data frame I want to access the second row. So I can use the locate function, df dot locate of B. So second row is accessed, that is 2.0 and 2.0. The second value is converted into float. Then this is slicing, B to D. B to D means B, C, D. So 3 rows have been accessed. And this is B comma D. B and D only, not in series sequence. So B and D. So B values are these and D values are D. We can also use we can also specify the integer to access a row. So I'm displaying a data frame here, and then I locate of 1. So means what is 1? 1 means second row. Index starts from 0, so 1 means second row. So it is going to display the output as 2.0 and 2.0. So this is the result. I locate of 3 means this is 0, 1, 2, 3 means the fourth one, the last one, which is having the label D. So this is how you can access a row by using locate and iLocate. You can also do slicing, means multiple rows can be accessed. So df of 2 to 4. This is a one way, just specifying the columns 2 to 4, and then iLocation. You can also use integer location of 2 to 4. So this way also you can access the rows 2 and 3. 2 to 4 means not 2, 3, 4. It is 2 and 4, 2 and 3, only 2. Then how to append a row. So I'm creating 2 data frames here. df1 is equals to, this is the data frame. So 2 elements are there, 1, 2, 3, 4. The column labels are A, B, C, D. Then another data frame df2. The elements are 5, 6, 7, 8. The column labels are A, B. Then appending. So append is the predefined method. Appending df2 to the df1, ignoring the index. Index equals to true. So this is the data frame appending this. I think this is also going to be removed in the future. Then deletion of row. So we can use drop, dropping the row label 0. So then first row has been dropped. The first is dropped. Then 1, 2, 3 are remained. So these are the basics of data frame, how to create and how to access and how to select and how to drop. Next, once the data frame is created, we can perform different operations. So here I'm creating a data frame and then printing the data frame. So this is my data frame. So once the data frame is created, you can apply some statistical measures also, like T. T means transpose. So df dot T, it is going to transpose. Transpose means rows becomes columns and columns becomes rows. So we are having three columns here, so they will be converted into rows. Name, age, rating. Four rows are there, so they are converted into four columns: 0, 1, 2, 3. So this is the meaning of transpose. Access means you can list out the access row and columns. So rows are starting from 0 to 4, step values 1 means incremented. Then what is the column label? Column labels are name, age, rating. Then another property is D type, means what is the data type of a data frame. So name is a object type and age is integer 64-bit and rating is float 64-bit. So we have three columns. We have three columns and then we want to display the data type of three columns: name, age and rating. So which are displayed over here. Then ndim means number of dimensions. Okay, number of dimensions. So it is two dimensional. So rows and columns. Then we are checking shape. So df dot shape gives you the shape. Shape means number of rows and number of columns. So we have four columns and four rows and three columns. So shape is 4 by 3. Then df dot size gives you the total number of elements. So 4 by 3 means totally we have 12 elements. Then the property values gives only the values. So these are the values without row labels and without column labels. And we are displaying the column here. Df dot columns gives the name of the column. So we have three columns: name, age, rating. And these head and to are the functions. These are very popular, but most of the time, so after loading your data, we would like to see the first few rows or last few rows. In that case, you can use head and tail. So if you simply say df dot head, so by default it is going to display first 5 rows. So we don't have first 5 rows, so it has displayed the first 4 rows. Or you can also specify the number. So I want to display first 2 rows. Head of 2 means displays the first 2 rows. Similarly, you can use tail. So if you don't specify any parameter here, it is going to display last 5. But if you give number 2, then it is going to display last 2 rows. So this is the use of head and tail. And you can also perform these statistical measures like count means number of rows, sum, mean absolute deviation, median, minimum, maximum, mode, absolute value, product, standard deviation, variance, right? And then skewness, kurtosis, quantile, cumulative sum, cumulative product, and this cumulative minimum. So all these things can be done on a data frame. So let us let us apply a couple of methods. So this is my data frame, and then I'm applying some method on the data frame. So then what it does is it adds all the um, rows. So age, in age, so 25 plus 26 plus 25 plus 23, so total is going to be 99. Can we add names? No, we cannot do that. Then they are displayed in sequence. And rating is numerical, so which can be added. So 4.23 plus 3.24 plus 3.98 plus 2.56, the total is 14.01. okay, 14.01 is the rating. So that is here the default axis is 0. Axis 0 means row, and remember axis 1 means column. So if you specify like this, df dot sum of axis 1 means you are adding columns. So when you add a column, so we cannot add a name with a numerical value, so that's why they are not added, but we are adding columns like 25 plus 4.23, which is going to be 29.23. Next 26 plus 3.24, which is going to add 29 point, which is going to be 29.24, like this. So these values are added and we are having four values here, 0 to 3. You can also select single column and then perform sum. So I'm performing sum on A's, and here performing sum but accessing the rows 0 to 3 means 0 to 3 means 0 1 2 only. So this is a addition of name, age and rating. Here accessing age and doing slicing here and then performing sum. So this is the value. Then you can also apply mean. Mean means average. So this is a direct method. Mean means average. Average age is 24.75 and average rating is 3.50. And here I'm accessing rows and then performing mean operation. So the 1 2 3 means 1 2 1 and 2 only. Then on A's applying mean. On A's column applying the mean, so which is 24.75. Similarly, you have standard deviation. STD means standard deviation. It gives the standard deviation on numerical columns. A's rating. Min means minimum value. So minimum name is K, because here on alphabetical order K comes first. Then minimum age value is 23. Minimum rating is 2.56. You can also access a particular column. In A's, what is the minimum value? That is 23. Then maximum is there. Max means maximum. Maximum name is S, because S comes at the last in the given names. And then A's. So maximum A's as per the data frame is 26. Maximum rating is 4.23. And then this described method is very popular. So the single function is enough to have a descriptive statistics. So it it applies the measures like count means number of rows, mean, average value, standard deviation, minimum value, 25 percentile age value, 50 percentile age value, 75 percentile age maximum. Similarly, same can be applied on rating. And this by default, this function will give the descriptive statistics for numerical columns. So as you can observe here, name is not there in the list. But if you want to have a descriptive statistics of object type of data, then you need to specify the parameter. Include is equals to object. Then it gives the descriptive statistics for only object type of data. And these are the descriptive measures on object type of data. Count means number of rows, unique values, top based on the frequency. So we don't have the repetitions, that's why each element is each name is one time only. So based on the frequency, it is giving us the top value, which is Ramesh here. Then the property like include is equals to all. It means descriptive statistics for numerical data as well as object type of data, string type of data. So as you can see in the list of measures, these first four, these are the measures on object type of data, and these are the measures on numerical type of data. So these mean, standard deviation, these are not applicable, so that's why missing value. Next, very importantly, pandas are used to load the data from different kinds of sources, like you have a CSV file. These are the input methods, input functions, getting the data from CSV, Excel, SQL, JSON, SAS, HTML, Stata, clipboard also, pickle means if you have saved a model, you can use pickle to load the model. And these are the output function, means once you have it processed data in the data frame, you can store them back into different formats like to CSV, storing the data in CSV format, Excel, like this. These are the output methods. So let us see a couple of important data types. So first, almost most of the time the data is in CSV format. CSV stands for comma separated value. So this is my file. I have some weather data here, and I kept in my data in my subfolder data. Then the CSV file is read. So this is the input method, read underscore CSV, reading the CSV file. Then the data frame is created. So this is my data frame. Or else you can also specify the complete drive path. This is the complete path, and this R means raw data. So by default, this Pandas supports Linux format. Okay, Linux format. Linux format means /. So but Windows use backward slash. So this in this way also you can create a data frame and you can display the header part of the data. So for more information you can also take help pd dot read csv and then question mark, means you are seeking help on the function. So this is the signature and the different parameters and what are their meanings, so you can go through that. And so we have a data in data frame 1. Okay, data frame 1 means this one. I just want to save this data in a separate CSV file, and I'm keeping this temp1.csv file, which is a new file in the my same data folder. Then it is going to be created. You can check that the same data folder. Then how to handle the Excel data. So at first I'm creating a data frame and then saving it, then reading back. So this is my data frame, name, age, values are there. The data frame is created, displaying the data frame, and then I want to store this data frame into Excel file. So this is a new file which will be created, and index equals to false, means we don't want to save the index like 0 1 2 3. So it is going to create a Excel file, and then first I'm doing output, means doing saving the data, then again reading back the same file. So this is the same data, I read it. Then SQLite is one of the database library, Python based library, which is used to create a simple database. So SQLite is very popular library which can be used in different mobile applications, because every mobile application stores data. So SQLite is used, and this is a Python library, so we just import it, no need to do the installations. So importing SQLite 3 as lights. Light means alias. So as we have already imported pandas, no need to import multiple times. Okay. And then here this file is going to be created. Okay, I'm changing the name here. This emp3.db is going to be created. So we have to establish a connection. So light.connect, the connection is open, and with this connection, so we are creating an object to the cursor class. So cursor means which is used to point out the records, and then creating a query here. So create table if not exist. If this table does not exist, it will create. The name of the table is emp, and these are the fields: employee ID, which is integer, primary key, name, which is text type, salary is float type. And then I'm inserting how many records? 4 records here. So 4 records are inserted into the table. Then I'm reading the data from the SQLite database table. So this is my query. Q equals to select star from employee. Then this is the input method, read SQL query. This is the query and this is the connection name, and then data frame is created. That means getting the data from database and creating a data frame. So this is the another query, select name from employee where salary is greater than 50,000. Salary is greater than 50,000. So how many records are there? So three records are fulfilling. This is the one, this is the another one, and then this is the one. This is less, so not printed. And using a for loop to print all the red records. Then we are selecting employee ID name from the employee. This is the another query. So employee ID and name. So here I showed you how to create a database and then table, then reading the data. So like this you can write any query by using by referring the API of SQL. Then how to load or create a JSON data. So here I am creating a data frame first here, and then A, B, C, D are the elements, index or row 1, row 2, columns or col 1, col 2. So this is the sample data frame, and at first I want to save. So you can take help on by this function to_JSON. So this is the syntax df dot to JSON, converting this into the JSON, and split means orientation split means dictionary kind. So you have to specify what is the key and what is the value. The structure is this: columns, specifying the list of columns, then index, list of indices, then these are the actual data. So it will create a data frame, and no, actually we have already created data frame here, and then we are saving that into JSON format. You can read it. So this is a read method. You can take help on this. So the same pd dot read underscore JSON, then from the current source getting the data. So we have loaded the same data set. So first we saved and then we read it. You can also create a JSON file. For example, if you have a data frame content, then for the data frame you want to create a new file, test.json. These things are same, orientation, columns, index, data, so all these things are same. Now this file is going to be created, test.json. Then reading the file, orientation is split. Then we'll read the data again back from test.json. This is how do you handle the JSON file. And next, most of the time data is also available in SAS format. So SAS is one of the statistical tool. In order to load the SAS data, we have to use this library pyreadstat. So it's a Python library, so you have to install it, and after installing, the function to read the stat data is this read underscore SAS. So I have a file downloaded from this URL, and then displaying the header part of the data. So these are the first three rows. So we read the SAS file. The extension is SAS7bdat. And if you have a data in data frame, then how to save that into the SAS format. So data from this file is going to be created, and index is equals to false. So it will create a file in the same directory. This is the installation, and you can install this library, and this is the function read underscore SAS7bdat, means you are reading the file and is going to create a data frame. So this is another file. There is no write method. There is no write method for this library. This library is not providing the write method. It is providing the read method. Next, how to read SPSS data. SPSS is also the tool, statistical tool. The extension of SPSS file is .sav. So I have a data downloaded from this URL and then reading the data from that. So this is the data frame. Then using the pyreadstat library, then this is the file, so it is used to read the data. Then we are writing, so pys is alias dot write sav, then creating a file sav, then this file is going to be created for your data frame 1. Then stata is also another data science tool. So if you have a data created by stata, the extension is dta. So I am just giving the URL directly here, atto2.dta. Then read stata is the method, read stata from atto. Atto is the URL, then the data frame is created. And then here I am using the pyreadstats libraries read underscore data. So data is read and we are displaying the first two rows. And then we are performing output operations. So write underscore data is the method. So writing the content of SDF2, and this is going to create a file atto2 underscore copy.dta in the my data folder. So this will save the data. So that's it about the pandas. So we have learned how to create two important data structures.